Welcome to The Explainer. Today, we're tackling one of the most frustrating phrases in all of technology, but it works on my machine. We're not just going to talk about it, we're going to show you how to banish it from your AI workflow for good.
So, you know the feeling, right? You've spent days, maybe weeks, getting your model to work just perfectly. You hand it off, you push it to a server, and boom, it all falls apart. Look, this isn't you being a bad developer. This is a systemic problem that absolutely plagues AI development. All right, so here's how we're going to fix this. First, we'll name the beast, the reproducibility problem. Then, we'll introduce our hero, Docker. We'll get into the core ideas of images and containers, run our very first one, then apply all that to a real AI workflow. And we'll wrap it all up with a super useful checklist. Okay, let's start by defining the villain of our story. AI reproducibility. It's that awful feeling when you realize you're not actually debugging code anymore. You're basically an archaeologist, digging through layers of hidden system files and weird dependencies just to figure out why something broke. You know, the biggest time wasters in AI often have nothing to do with the complex models. It's this stuff. It's a dependency that quietly updated itself. It's a mismatch between your CUDA version and your framework. Or maybe the server is just missing one tiny, obscure library. These are the little things that just absolutely kill your momentum.
So, what's the answer? Well, it's a huge shift in how we think. Instead of just writing down setup instructions in a text file and, crossing our fingers, we need to start treating our entire runtime environment the same way we treat our code, as a version-controlled, shareable thing.
And that is exactly what Docker gives us. It creates what you can think of as a runtime contract. It's a rock-solid promise that your code, all its libraries and all its dependencies, will run the exact same way every single time, no matter where you are.
Now, you might be thinking, hang on, isn't this just a virtual machine? And that's a fair question, but the difference is absolutely critical. A VM has to pretend to be a whole other computer with its own operating system and everything. But containers, they're way smarter. They share the operating system kernel of the computer they're running on, which makes them incredibly lightweight and ridiculously fast. We're talking seconds to start up, not minutes. So, to really get Docker, you only need to understand 3 core ideas. Seriously, once you see how these 3 pieces fit together, the whole thing just clicks. First up is the image. Think of this as the blueprint for your application. It's a static, unchangeable file that has everything your app needs to run. Your code, your libraries, system tools, the whole shebang. You build it once, and that blueprint is locked in. And then you've got the container. So if the image is the blueprint, the container is the actual house built from that blueprint. It's the live, running instance of your application. And the really cool part is you can spin up hundreds of identical houses from that one single blueprint. And finally, we have the registry. This is basically where you store all your blueprints. The best way to think about it is like GitHub, but for Docker images instead of code. It's the central place where your team and your servers can pull down the exact right blueprint every time. So the whole process just flows together beautifully. First, you build your code into a static image. Then, you run that image as a live container. And finally, you distribute that image by pushing it to a registry so other people can use it. Build, run, distribute. It's that simple and that powerful.
All right, enough with the theory. Let's get our hands dirty and actually make this real. We're going to go from nothing to a running container right now. So go ahead and open up your terminal and type this one simple command, Docker run hello world. What's happening here is Docker is automatically finding that image online, downloading it to your machine, and running it. If you see a little hello from Docker message, congrats, you're all set up.
Okay, let's try something a little more interesting. We'll run this command here. Now that -p flag is the important bit. Think of it like a tunnel. It forwards traffic from port 8080 on your machine to port 80 inside the isolated container. So if you now open up a web browser and go to localhost 8080, you'll see a web page that's being served from inside that container, completely separate from your machine.
Okay, so that was our hello world. Now for the real payoff. Let's see how we can use this exact same logic to package up a real, actual machine learning training script. This is where Docker really starts to change the game for AI.
This right here is a Docker file. It's the recipe for building our AI blueprint. Each line is just an instruction. We start from a basic Python image. We copy our list of dependencies in, We run pip install to get all our libraries, and then, at the very end, we copy our actual training script inside. It creates this perfect, self-contained little package.
So we build the image from that file, we run it, and there's our result, an accuracy score of 0.947. Now, the number itself doesn't really matter. What matters is how it was generated. That entire training job ran in a perfectly clean, totally isolated environment that didn't touch our local Python setup at all.
And that right there is the magic moment. You've completely separated your project's runtime from your own machine's environment. Now, literally anyone on your team on any machine that has Docker installed can grab your image and get the exact same result. Perfectly, every time.
So how do you actually start using this in your own work? Let's wrap things up with a quick checklist of best practices that will make sure your AI projects are reproducible from day one.
Look, adopting these habits is what really turns Docker into a professional engineering tool. Always pin your dependency versions. Keep your images small by using a .docker ignore file. Tag your images with something useful, like a git commit hash, so you know exactly what code is inside. And maybe most importantly, treat your containers as disposable. You don't fix a running container, you just throw it away, update the blueprint, and build a new, better one.
If you remember only one thing from this whole explainer, let it be this. The Docker image is your unbreakable runtime contract. It is the single source of truth for how your app is supposed to run. And that makes everything that comes after, collaboration, deployment, predictable, reliable, and honestly, beautifully boring.
By mastering this workflow, you're not just learning a new command. You're fundamentally eliminating one of the biggest bottlenecks and time sucks in all of AI development. Your runtime is no longer a source of chaos and frustration. It's just another versioned artifact sitting right next to your code. So the only question left is, what are you going to build with all that extra time?